Welcome to episode 9 of Sustaining the Herd, Manure Management for Digester Developers 101, Water, Hoof Blocks, and Neck Chains. I'm Andrew Wadle.
And I'm Brock Vitek.
Thank you for joining us today. This episode of Sustaining the Herd was born out of really our experiences and involvement with digester developers and farm owners when it comes to planning anaerobic digestion systems, and some of the things that we find people run into that are really not anticipated. And some of that is, well, what is one of the most important things that for a digester is the manure going into the digester, or the feedstock going into the digester. And boy, it sure is really easy to go to an NRCS table for what, say, is in manure, and kind of build a pro forma or build a model around that. And really, it turned out not being reality. And so this episode is really intended. We're kind of tongue in cheek calling out digester developers here, but really, it's for anybody that's involved in putting together a digester project. Putting together a digester project could be the digester developer, it could be equipment suppliers, and it could be the dairy or feedlot owner or swine facility owner. So this is kind of something for everybody, but really we're going to be focusing on anaerobic digestion. So this also really kind of plays into what we have going on in the future, in that in our work with the American Biogas Council, we will be putting on a session called Symbiotic Solutions, Harmonizing Biogas Systems and Farm Operations. So this will kind of be a warm up for that. And really, that name of that session really is intended to get people thinking about how do you basically meld a digester system with the farming operation. The two have got to coexist hand in glove. So on that note, speaking about American Biogas Council, we're at Setch Agri-Services and Engineering. We are huge supporters of the American Biogas Council and their training sessions, and we're thankful for the opportunity to participate in those and share with you some of the things that we've learned taking part in those events. And so on that note, I'm gonna kick it over to Brock and say, Brock, can you just give our audience what makes for a good anaerobic digestion substrate or a feedstock?
Thanks, Andrew. That's a great question. And I might back up one step and first ask, what is anaerobic digestion? I imagine most of our listeners, if they've come for a few of our episodes, they have a general idea of what it is, but on a technical level, what is it? Well, anaerobic digestion is the breakdown or degradation of organic matter, organic material, by microorganisms. And those microorganisms that ultimately make the methane are called methanogens. They are archaea, ancient bugs, to put it in layman's terms. And I think the question at hand here is what food do those bugs really like to eat? What makes for a good substrate? Well, we know that most anaerobic digestion systems, for purposes both of practicality and economics, have a hydraulic retention time of around 30 days. And by hydraulic retention time, I mean that is how long that material, substrate, is retained in the digester tank or reactor before it is spit out of there to be further processed and potentially applied to land for fertilizer. So we need substrate that can be degraded and produce energy in the form of methane or biogas in the process in around a 30-day time frame. So that's the first thing that makes for a good substrate, something that can be degraded relatively quickly, not something like lignin cellulosic material that takes a lot longer, something that can break down fairly fast. And it has to contain a decent amount of energy. If the bugs are going to all that work, we want to make sure that the juice is worth the squeeze, that after the archaea have broken that down, that they're not just getting a small amount of methane, because that's inefficient in many ways. It needs to be worth their time to degrade that organic matter. And a more practical consideration is, we know there are a lot of different feedstocks and substrates available, but they need to be somewhat easy to homogenize as well. By that, I mean something that can be ground up, macerated, mixed with water, and put into a slurry form, anywhere from, let's say, 8 to 12%, excuse me, total solids. And that slurry goes in the digester, not something with big chunks or strands that could get tangled up in mixers and just cause a lot of practical problems inside of a digester.
Yeah, those are really good points, Brock. And can you just give folks an idea of the concept of biomethane potential?
Yeah, I'd love to. So biomethane potential is yield of how much the expected yield of methane that we would expect from any given feedstock or substrate. This is something that I've had a lot of experience with here at Sechi Agri-Services and Engineering, where I've gone and sampled a lot of feedstocks ranging from manure to other waste streams from food processing and other industrial processes. And we send a sample in to a certified laboratory, and they take just a very small amount of that sample and put it in it's almost like a test tube scale test, I would call it. And this runs for around 30 days, and they monitor how many milliliters of biogas and methane are produced by that. And that gives us an idea as to what to expect as we scale that number up for a full scale plant, realizing that there are certainly some considerations and differences between a test tube and a 2 million gallon digester tank with mixing, but just gives us an idea what yield we should expect from any given material. That's really where it all starts in terms of assessing substrate feasibility for digestion.
Right. And is there any benefit to adding substrate to a digester that has no biomethane potential?
There is not.
So that's a really key point, Brock. That is, we don't want to be adding material to a digester that just doesn't produce gas. It's really that simple, because what it does is it increases the size of our reactors for no value.
That is correct. Andrew, what are some things found in manure that people would never expect?
Well, I'd like to say we've seen it all, but as soon as I say that, we'll visit a facility and see something different. Um, so, the things that we would expect to find in manure, we can really sum up quite simply by saying, if it crosses over the boundary onto the facility, whether it be the dairy or the feedlot or the swine facility, if it can get on the property, it can get in the manure. And so, to just to give some idea of what that could be, um, hammer handles, hair, uh, afterbirths, machine parts, almost anything that you could imagine. Or, for instance, hoof blocks. Most people aren't familiar with hoof blocks are, but they're key to keeping dairy cows' feet healthy. And so the list goes on and on and on as far as the things that we would expect to find in manure. And quite ironically is the fact that these things that we would never expect to see in manure, they really have zero biomethane potential. And so, back to what Brock was saying, we don't want to be adding anything to the digester that would have the potential, or that would have no biomethane potential. The other component that's considered manure that isn't manure is water, and so we see water going into digesters, and we'll talk a little bit later about what the effects of water. But yeah, those are some of the things that we would see in manure. And as digester developers, you know, you really need to be planning for these things, and that is, whether it be screening them out of the uh, of the feedstock or some other means like that. But those things need to be taken into account, because hoof blocks and hammer handles and things of that nature really wreak havoc on things like mixers and pumps and pipelines and things. And so it's these things that we never expect to be in manure that really can be the most problematic, and problematic in the sense that they could be catastrophic in terms of being harmful to equipment. And if equipment goes down, perhaps our digesters are going down. If our digesters are going down, we're not producing gas. And if we're not producing gas, we're not producing revenue. And so those things that we don't expect are the things that we really need to get out of manure.
Expect the
Uh,
unexpected.
definitely expect the unexpected. And as I said in the opening, of those things that I just mentioned, hair, hammer handles, water, they aren't in the manure production values, for NRCS. Um, th- when you're an aspiring agricultural engineer, you know, being taught the aspects of designing manure systems, they don't teach you how to pump hammer handles and things like that. So it's definitely not textbook stuff, but it is reality. And and so something else that's in manure is ash or grit. And Brock, where does grit, or ash, non-organic matter, come from in a manure stream?
It can come from a few places, Andrew. One source that a lot of people don't always think about or realize is that manure, as excreted, like fresh out of the cow, contains ash and grit because we know that there is a decent amount of mineral content in the feed ration for livestock, and that mineral content is not necessarily organic. Some of that is utilized and taken up by the animal, and some of that is passed through. And even though it may be a small amount, at the end of the day, that is inorganic matter in the manure that once the organics are degraded in a digester will remain, and that's either going to settle out in a digester tank or pass through in the effluent stream in the digestate. And so that one source, like I said, can be just from the feed ration, what it's composed of. However, there also could just be free dirt or grit, sand in the ration, just from the feedstuff production process. Forage is produced in a field which contains soil, dirt, sand. We know that there's dust in a hay bale, right? I think a lot of us have experienced that. Well, that carries through all the way to the feed bunk at the feedlot or the feed wall in the freestall dairy barn, and the cows are consuming that. Another source coming from the operation might be when a skid steer comes through to push manure in an alley. Well, it's probably coming from outdoors. May pick up some sand or some dirt on the tires, or if it rained recently, could be mud on the tires. That's getting tracked in the alley, getting scraped, mixed in right with the manure, and that's all going to ultimately end up in a digester.
Yeah, absolutely. And same question, but what's the biomethane potential of ash and grit, Brock?
The last I checked, it's been a while, but last I checked, I think it was a big old zero in my
That's right.
notes.
So, Brock, what percentage on a dry basis would you expect to see grit in say dairy manure?
Yeah, Andrew, I'd say, the percent ash on a dry basis for dairy, I'd expect around 10% on the low end, no more than 20% on the high end. And, then as we think about feedlot cattle, could be similar, if not higher, just a lot more variability in a feedlot system.
Right, because for a feedlot, it's going to depend on whether it's conventional pens or roller compacted concrete, right?
And it's outdoors, so could be some more blow dirt and blow sand mixed into.
Yeah, yeah, absolutely.
So, Andrew, a little bit ago, you mentioned water. So I'd like to ask you, why is there so much water found in manure, particularly at a dairy, and what are some of those sources?
Yeah, so just to put that into perspective, we could have manure that, at say, comes out of the cows at um, 12% total solids. And real quickly, it can get diluted down to about 6% total solids. And by no means a matter of squandering water. It really is a matter of what it takes to produce food. You know, so first, what is milk? Right, milk is a perishable food, and so we need to keep it refrigerated, keep it cool. Well, water is used in the process of cooling milk or pre-cooling milk before it gets shipped to the processors. And so the one reason we have water in manure is because, well, we want to keep our perishable product from perishing. And the other part of that is, you know, in a dairy, say, we're piping milk all throughout the milking parlor, and then to where it's loaded out, and all that piping and processing equipment, it needs to be cleaned. And for the piping to be cleaned, it's done with water. And so the first big source of water, and this and not any particular order, but water is used to keep milk from perishing or from going bad, and also to keep the equipment clean, to keep the bacteria in the milk low. Uh, the second thing is cows. Dairy cows are mothers. They're postpartum mothers, and so they've just had babies in some cases, and we want to be taking really good care of our mothers, right? Everybody wants to be taking good care of their mothers, and so uh, the milking process, the actual process of harvesting the milk from cows, or the environment that the cows are kept in, needs to be kept as absolutely as sanitary as possible. And so fresh water is used to, say, clean standing surfaces, so that the teat ends that are just dilated potentially from producing milk, the teat ends have less exposure to bacteria. And and so um, and so that's a decent amount of water is used there, and we can go right on down the line when it comes to taking care of our mothers. Dairy cows are need to be kept, in addition to being kept clean, they need to be kept comfortable. And so in most of the places, or many places where there are dairies, water is used to cool cows. And just like when you hot day mowing the grass, say dump hot water or cold water over top of your head, and you can just feel the heat leave your body. Cows are the same way. And so dairy cows, as they are eating, in many cases, we are cooling them by putting water on their backs and blowing fans across their backs, just to kind of to drop their body temperature. And yeah, some of that water evaporates, yes, but a lot of it doesn't. And so uh and so why do so short answer to your question, Brock, is why do we use so much water? It's really to preserve the food, and to keep our cows healthy, comfortable, and producing as much milk as possible. And that is really key to sustainability, is taking care of our animals.
Certainly. To sum it up, cows are mothers and milk is food.
Cows are mothers and milk is food. That's correct.
So we just talked about water. We know there's oftentimes something else found in manure. So I'm going to ask you, why is there sand in manure?
Well, the why is there sand in manure? And we talked a little bit about ash and grit, and sand is kind of like a subset, if you will, of those things, because they really act the same way. In that, first they settle, and second, they have zero biomethane potential. And going back to our discussion about ash and grit, it's really important for our digester developer friends, especially the ones that have just come to the scene recently, to understand that you know, ash and grit kill digesters or the previous coming of anaerobic digesters and in relatively small quantities. So it is a problem getting into a digester. So then why is there sand in manure? Sand is used for bedding for cows because cows are mothers and we want them to be as comfortable as possible. And people ask, well, why sand for cows? Well, a couple of reasons. One is it's soft. It's the same reason when you go to the beach and you drop your carcass down into the sand. It's comfortable. Well, dairy cows, all 1,500 pounds of her fall. You ever watch a cow lay down? It's almost like a controlled fall, right? And so these big bodies, when they go about laying down, we want it to be on a surface that's as comfortable as possible. So sand has some cushion. It kind of like pushes away from the body. And then also sand is inert. So if you take a population of bacteria and you put it in sand, it's either going to live out its life, or it's going to die. And you know there, because sand is inert, it's not a carbon source, and so therefore there's no food. The bacteria can't propagate. It's unlike, say, a green bedding or something like that, where you take bacteria and you put bacteria in green bedding, and the bacteria say it's party time, and the population goes wild. So sand is in manure really for bedding. It is for cow comfort. Just like water, it's to keep the cows comfortable and clean and producing as much milk as possible for as long as possible. We want cows staying in the milking herd for as long as it's economically feasible.
Definitely. And Andrew, to give those developers and the rest of our audience who are listening a sense for how much sand that could be entering the manure stream going to an anaerobic digester. Let's think about a 1,500 pound Holstein cow having a controlled fall, right? Every time she lays down, we know that sand's not going to stay neatly contained in her stall. It's going to get out in the manure alley. How much
Yeah,
sand per cow per day could realistically be flowing towards a digester?
yeah. And that's actually one of the benefits of sand, is that when cows move out of free stalls, they're not graceful. It sounds like I'm picking on cows, right? That they fall down and they're not graceful. Well, it's true. They fall, they fall down to lay down, and when they move out of stalls, they kind of drag their feet. They're not very graceful. And when they drag their feet, they are kicking sand into the alley, out of the stalls into the alleys. And here's the number that really surprises people, and that is typical sand usage. When sand is used right, it's at about 50 pounds per cow per day. 50 pounds per cow per day, which works out to about maybe a third of a cubic foot per cow per day. And it is substantial amounts, uh, compared to even the grit that you would find in just in feed. So um, so we have 50 pounds per cow per day. Many people have tried it. We get asked the question all the time: can you digest undiluted sand laid manure? And the answer is, based on the suite of technology available now, the answer isn't just no, the answer is heck no, because it is such massive, massive quantities of sand. However, there are many, many digesters throughout the US and throughout the world bedding with sand with anaerobic digestion. And they do it by separating the sand before it goes into the digester. And so you can have sand bedding with digesters, but you have to be separating the sand beforehand. That having been said, doesn't matter what the process is, doesn't matter what the separation process, what the brand, who designs it, whatever, it's just nothing's 100% efficient. And so you're always going to have some bypass sand in addition to the sand and grit that might have come off the field. So if you take 2% sand bypass, times 50 pounds per day times, say, 5,000, 10,000 milking cows, you start adding up substantial to substantial amounts of sand. So even in terms of just bypass sand. So our digester developer friends just need to come to grips with the fact that sand is really part of life, and by by not working with sand dairies, you're potentially excluding a significant portion of potential potential candidates. And but on the same token, for our dairy farmer friends, it is possible, if you are sand bedders, it is possible to separate the sand to the extent that you have a product that's amenable to anaerobic digestion. And I just wanted to say a couple words on things like, back to the water usage and sand bedding. You know, if you're a digester developer, you can you can make suggestions to dairies to, say, use less water or not use sand. But I think you have to be very careful, because if you are adamant about those things, you potentially own, and I'm making air quotes, you own those results. In that, if cow health suffers or milk quality suffers, etc. So you have to remember that dairy producers are going to be dairy producers first, and there can be all kinds of enticements in terms of all the mad money to be made from biogas. But at the end of the day, dairy producers are dairy producers. They're in the business of taking care of animals and producing milk.
Definitely. No, that's all really important to think about, Andrew. And you mentioned it's something to come to grips with. And speaking of those types of things, I'd like to switch gears a bit back to earlier. You said dairy manure might be excreted at, say, 12% total solids and be diluted to 6% total solids pretty quickly with all of the water sources at a dairy. So I'd like to ask you, what happens when manure is diluted?
Yeah, and that 6%, as you said, as I said, you get there pretty quick. And if you go to western states, or particularly southwestern states, it can very easily go lower than 6% into the low single digits. And here, this is just a for developers to understand this, uh, that when you're a dairy producer in an arid region, you're irrigating crops. You're irrigating crops like crazy. It's the lifeblood, so to speak, of a crop production system. And so, to a dairy producer in an arid region, you know, using water on the dairy to do things like flushing alleys and whatnot, it's really not seen as being it's not really seen as being a big concern. I'm using, quote unquote, a lot of water, because that water is then just going to be turned around and used as an irrigation source. But not only irrigation source, but a fertigation source, because now it's picked up some manure nutrients along the way, and basically going to be doing double duty. So if you're a digester developer and you're planning a digestion project in an arid region, certainly come to grips with or understand how your goals of reducing water usage are maybe not in conflict with, but very very divergent from where the dairy producers are. So, Brock, to your question, what happens with dilution? So, when you dilute manure, you decrease its viscosity, and when you decrease the viscosity, you cause settling. So besides the fact that water as a diluent has zero biomethane potential, uh, you know the next biggest concern is that the viscosity drops, and now this sand or the grit or anything is now wanting to settle in those tanks. So think about it: when the manure is sticky and more viscous, all these things that want to settle, they're more inclined to stay suspended in the stickiness of the manure medium. But once you dilute and dilute some more and dilute some more, and you break that stickiness down, and those heavy particles can overcome the viscosity and head to the bottom of a tank. And so we all know that there's going to be bypass sand. We know that coarse organic matter settles. So it's funny how everybody whenever digesters fail, everybody tends to blame the sand. It's kind of like an electrician friend says, when a house burns down, they always blame the electrician because they think they can't blame the plumber. Everybody blames the sand, but the sand isn't always the problem, because a coarse organic matter particle will settle the same as a fine sand grain. And so I've seen digester tank cleanouts before, and they take the cover off or they open the hatch, and what do you see? Well, you might not see sand. You might see a huge pocket of undigested corn kernels, like you said, Brock. Corn kernels and these lignans, they don't digest in a 30-day hydraulic retention time, and so they these big organic particle, it settles to the bottom, and we call them a coarse organic particle. We can call it wannabe sand. It's sand. It's a particle that wants to be like sand, the way it settles. So what does this mean to a digester developer? It means that we need to have some source of agitation. Forget sand bedding. Even say it's just green bedded, manure bedded dairy. It's fine. You still are going to have some means of agitation to keep the particles in suspension, and suspension, because of the fact that you have these particles that are going to want to settle to the bottom of the tank. And you have two things to consider. One is you want to keep the particles elevated, that is up in the bulk fluid swirling around. But then in the same token, if you're agitating up, that is, if particles are moving up, other particles are moving down. And so you have particles headed to the bottom of the tank. So not only do we want to keep them suspended, but we want to keep them scoured or moving along the bottom of a tank and then up back into the bulk of the manure flow. So dilution is kind of a way of life on dairies, and but it's the good news is that everything that we talked about, it's not insurmountable. We can strain or screen some of these weird things like hammer handles and bolts and things. We can screen them out of manure. We can separate sand from manure. So it's not a doom and gloom situation. It's just a matter of going into projects, being completely aware of what the landscape looks like.
Definitely. That's great, Andrew. But before we move to finish our conversation here for the day, I'd just like to go through, I think, some key points for developers and all of those listening to consider. First, know your substrate. Is it a good or bad substrate, with the things that we talked about, and keeping those in mind. Number two, expect the unexpected, such as hammer handles and hoof blocks and neck chains and other things you might find in manure. Also, think about ash and grit, particularly sand, whether it's coming from the bedding or from the manure itself and the feed ration. Also, don't underestimate water. It is there. There may be a lot of it depending on the livestock operation, and it's something that at the end of the day you have to deal with. And finally, no matter what suggestions you might make as a developer to the livestock producer, you own the outcome, as Andrew said. You really do own the outcome, positive or negative.
Yeah.
And finally,
Yeah.
I would just like to say, I know we've focused a lot on digester developers in this episode today, and as Andrew and I mentioned a couple of times, this applies to everyone, especially farmers and livestock producers, whether you're a dairy, swine, or feedlot producer. Because if you're approached by a developer, these are the types of things that they will need to sort through to determine whether or not a project is feasible for your operation. And it could be really helpful for you as a producer to know of these things already and be able to start to think through some of these items and have a better conversation and hopefully a better feasibility assessment process with the developer. So I think what I'm trying to say is there's value here for everyone who might be listening, and these topics shouldn't be taken lightly. They really are important for an anaerobic digestion project. So with that, I would like to thank you all for joining us today for episode number 9 of Sustaining the Herd, focused on manure management for digester developers, 101, as we'll call it. And, it's hard to believe that this is episode 9 already. Andrew and I have been having an absolute blast with all of you, all of our friends here in the herd, as we like to say, our great listener base. We're excited for our next episode to be number 10, a big milestone for us here in a couple of weeks. And we're working to have a great episode for you all to listen to here soon. So, with that, once again, we'll remind you that at the Business of Biogas Conference in St. Louis on October 24th, we will be hosting a session called Symbiotic Solutions, harmonizing biogas systems and farm operations. So if you've enjoyed anything that you've heard here today, we encourage you to sign up for that great event by the American Biogas Council and come to learn more during that session. Until next time, thanks for joining the herd today.